afternoon, everyone. So what I'm going to talk about is fleet optimization through process information. So I'm from the power generation business, and so all my experience would be relating to power plants and the happenings in the power industry. So this is going to be our journey for the last 10 years of how we evolved in terms of technology and how we came into this area of remote operations management. So basically, here's an example of our remote operations center that's located in Ann Arbor, Michigan. So there are a lot of drivers for this particular remote operations center, changing business. We are operating in an area in a time when we didn't have any access to any information. This was about 10, 12 years ago. But right now we have sort of an information overload. So we had quite a few of these challenges, and simply getting to the grits of it today, the agenda for today is I'm going to show about our remote operations center, talk about our control and technology pyramid. That's the foundation for all the technology that's out there. We're going to look into some application examples. I'm going to show you some of the work that's in progress right now, and then after that, the panel discussion. So here's a little bit about DTE Energy. So it's a company, a diversified energy company, headquartered in Detroit, Michigan. Our Detroit Edison is the electric arm. It's the regulated entity of DTE Energy, and I'm part of Detroit Edison. And size-wise, generation capacity about close to 12,000 megawatts, about 2.1 million customers. So pretty much majority of the auto industry load is served by our company. So here's a listing of all the power plants that we have. We have quite a mix of all kinds of power plants. Majority of them are fossil-fired, using coal, but we do have gas-fired, oil-fired plants, and also a nuclear power plant. And then here's the listing of all the generation capacities in a tabular format. And then expanding renewable portfolio. This is our expanding space where remote sites are cropped up. We have various wind farms located in various remote centers, and those are all being monitored from our remote operations center. Renewable portfolio standard mandates that, at least in Michigan, that 10% of our generation has to come from renewable sources, and wind turbines is one of them. So all of the things that we have done, we've done it through a technology pyramid. It's like a blueprint that we've been following for about the last 7, 8 years ago. And this blueprint still holds for today. So I'm just going to quickly run you through the whole pyramid and then walk you through examples from layer by layer. So the bottommost layer of the pyramid is where all of your control systems are, distributed control systems, your auxiliary PLCs, etc. Those are all your data sources where there is information being generated. Data is being generated, and all of this data is being captured into a data historian. So for us, that historian is made by OSI Soft. That's Pi, a Pi system. And that becomes the repository for all of your data. So the intent of this particular technology pyramid is to convert that data into actionable information. So how do you extract information out of this data? We're talking about gigabytes and terabytes worth of information. So this technology pyramid is how a structured approach on turning data into information. So the first of that is we have a lot of engineering applications. Once you have information, what you do? A lot of engineering applications for various business needs. The next set would be visualization. How do you make this information available to the whole fleet? People should be able to access this information from anywhere. Following that would be system dashboards, meaning focusing on different major aspects of your business. For power generation, it could be systems like a condenser system or a turbine system, etc. Then, after that, we'll get into the area of expert systems where you're trying to predict. You have lots of historical information. You're trying to predict when an equipment fails, when a process goes out of whack or deviates. Closed loop optimization, those are all of the expert systems in that layer. Then following that would be your integration with your business systems, how the engineering data is being blended into your into your business systems, and that's where that particular layer deals with. And finally, basically, the topmost layer of the pyramid is nothing but an amalgamation of people, processes, and technology. So, again, here's our remote operations center. The analogy that I give to people when they ask me what does this do is, you could say it's your NASA command center, or as I like it to call it, it's basically your air traffic control. So the plants are located remotely. They run the show. The control room, the operators at that plant, they run the show. They are like the pilots in an airplane. But the remote monitoring center is the one that's directing them what to do. And they're warning them, hey, here's an impediment, here's the weather changing, here's what's going to happen. So all those directions are being provided by our remote monitoring center. They are staffed by very experienced people from operations background, typically people with about 25 years of operating experience in a power plant, from the technical background and from the engineering background and the operations background. So let's go through the pyramid one more time and look into some of the applications. As I said, the bottommost layer is where you have majority of your data. So PI system are all propagated throughout our company. Every plant has it by default. Every new location that comes out will have a PI system. Obvious advantages, it's one single source where all information gets aggregated, captured, and you can exchange information from one location to another location very easily using the PI to PI system. Now, for the remote monitoring center, they need to monitor data from every site, so you capture information from all the sites. Right? Here's a typical technical structure of a plant. A plant may have anywhere 20 to 30 data sources at the control system level, PLCs, auxiliary systems, DCSs together. But where they converge is all the data goes into the PI system, and that's central to everything. Once you have your raw information, what can you do? You can do a lot of data analysis, and people do it. It's just simply looking at these data points. You can do some trip analysis, some optimization. All those can be done. But the bottom layer is expanding. Now, from a generation side, we have a lot of this information on the plant side, but when we distribute power to the customers, as I said, we have 2.1 million customers, and we have a, you must have heard the term smart grid, smart homes. Part of that is there are smart meters being rolled out to the customers. So when we roll out these smart meters, each customer has a smart meter in his home that's capable of giving about 25 data points. 2.1 million customers, you can do the math. So as of today, we have rolled out about 1 million of these smart meters, and so we're capturing about 25 million PI tags. Valuable information, okay, remotely being done, but so we have a huge infrastructure of PI systems capturing information from the customers. So the point being, the bottom layer is expanding, and it's going to expand. So I'm going to focus the rest of the presentation just on the generation side of the business. Now, as of now, probably there are about 800,000 data points just on the generation side with DCS installations and PI installations everywhere. So the challenge is, you're like, where do you find the needle in the haystack? That's the analogy, basically. So what's this data telling you? How effectively you're going to utilize this information, and then how do you turn data into information? Those are the challenges, and then the technology pyramid is the way we're trying to address it. So once you have data, as I said, you do a lot of engineering applications. So what are you going to do with the engineering applications? Some examples. Power plant is a huge thermal cycle, so all of your thermodynamic calculations for the mechanical engineers, all the inputs are coming from PI. The calculation engine just computes, crunches the numbers, and writes the values again back to PI. That's one example. Number two, coal-fired utilities, burn a lot of coal. So that's our 95% of our expense is procuring fuel and fuel-related expenses. That is 95%. So close to $1 billion at one location we spend on just procuring coal. That's our fuel expense. So we monitor that. So all that is done through PI. So that's another example of an engineering application. So the third one is your emissions monitoring. So power plants emit a lot, and there is an emissions trading floor. For example, if you emit NOx, there is, NOx emissions are being traded in the market. So with PI, what we do is we use it to monitor the real-time operation of a plant, and the value of that emissions is basically traded in an emissions floor. So you have to capture the market value. That is done through a interface from OSI soft, which is called PyHTML. It just goes on the internet to any website, capture a data point, bring it back. So what we are able to do is the emissions that we put it in the air, immediately we compute what is the value of that. So that goes into part of our emission strategy. Then finally, there are several processes in the plants. For example, operators are required to periodically go out and record readings, do their rounds. All of that is done through mobile devices, and that information, again, is stored back into our Pi system. So those are some examples of engineering applications. Now, the next layer is where we talk about the fleet-wide monitoring. So we were doing a lot of point-and-shoot applications at a unit level, at a plant level. We never thought about from a fleet perspective. And this is about 2005 time frame. That's where our company was getting into a market where we were going to actively bid all of our generation into a market. It's called an independent system operator market. In the Midwest, it's controlled by an entity called MISO, Midwest Independent System Operators. So we're going to compete with about 15 other utilities in the Midwest region, and then the cheapest person gets to, generate. The expensive units are going to be shut down. So it is impetus for us to run the fleet from a fleet perspective, the whole business together, rather than just look a plant manager running his particular plant. So one of the first things that we wanted to do at that time from a fleet perspective was give ability for people to look at your information, which means you're going to have a lot of methods involved, and also quite a few of the departments involved. Pretty much all of your various groups within your organization have to be a part of this fleet-wide monitoring solution. One of the first thing is ability for people to view this information on a web portal. Okay, so this was done about 2005, 2006 timeframe. Here's an example of a display where you can see all of your generation from every single unit in your portfolio. Another example of all the major pieces of equipment and their statuses. And majority of you know that control systems are very isolated networks, which means operators, when they are controlling a unit, the distributed control system graphics are not available on your corporate business network. But that information is stored in Pi. So what we have done is we have replicated about 6,000 of DCS graphics into the Pi system with the Pi data as the background. Now, the remote operations center has a same look and feel of all the units in the fleet. So 19 units, all the graphics done in this particular system. Now everybody knows what the plant operator is doing in real time. And this is one of the reasons why a remote monitoring center came into being. That's the primary reason. A virtual control room. You can do some simple data analysis with this information. You can actually replay events. Well, you had a unit outage last night at between 12:01 and 12:06. Okay, what was the operator doing? You can just go back and replay the events and watch what he was doing. Another example is a wind turbine. It's an AF element relative display. I'm going to talk about it later in the presentation, but another example of a display there. Mobile workforce. Let me tell you, here's the space that is rapidly changing. We're doing quite a few things because, as you see, the mobile platforms that have come into being right now, there is a lot of testing going on right now in our company. A lot of new applications will be rolled out. But as of today, what people can watch is you can see exactly what your units are generating, some statuses of equipment. You can see the engineering parameters on a turbine. I can look into how well you're doing in the market, the load trends of the whole Southeast Michigan. You can also look into if there are any outages and how the customers are getting affected. So all that was done through the mobile effort there. Now, after the web displays were done, we started focusing on system displays, saying that, okay, you have expertise in various systems in the plant, right? So you have a turbine expert, a coal mill expert, you have a generator expert, and his focus is purely on his piece of equipment. You have generators in every plant, So his objective is to monitor that piece of equipment and nothing else. So we created quite a few of these system dashboards. An example would be if you want to monitor all the 110 coal mills in the fleet, you have it available to you. That's the status of it. You click on it, it shows you detailed engineering information of those coal mills. The next layer is called expert systems. This is where we're talking about predictive type systems. So we've had the first PI system since 1999. So we have history for about 13 years right now. So it's valuable information regarding your equipment. If you do some sort of statistical analysis on that data and you have some pattern recognition software that's going to take all this historical data and it will be able to predict of an impending failure. And that's what a system, this smart signal system does. Typically how it runs is you have in a control system, you have an upper limit and a lower limit. When you hit those limits, there's an alarm, an audible alarm comes in a control room, which means by then the damage is already done. So you're in a firefighting mode at that point. What this particular equipment monitoring system does is it's correlating a data point to all the data points, all the inputs of that particular equipment, and it's trying to alert or a statistically deviating process well before it hits any of the control limits. Sometimes it can warn you of a failure like 45 days in advance. And very important for you when you are trying to bid your generation into a market. You know exactly that that equipment is faulty, it might come down. So you can hedge your bets very well. So we have about 1,800 models on this particular predictive monitoring software on all these pieces of equipment. Then we're going to get into the next layer, which is your business intelligence layer. And I'm going to show you a couple examples. One that is already in use. The second one is a work in progress. So the first one is, as I said, we are part of a independent system operator market where we have to bid generation. So how we do is, excuse me. So we have a daytime market, a real-time, day-ahead market, a real-time market, and a market strategy. So all of your generation statistics are coming from your power plants in real time through the PI system. This information, along with our predictive monitoring software, they use this information at our remote monitoring center, and then it devises a market strategy on which unit to be offered, when it needs to be offered, at what price it needs to be offered. Once the strategy is figured out, that information is sent to MISO. And then whether your bid was accepted or rejected, that feedback is sent back to the plants. Now, the plants know that, well, you have to generate X number of megawatts for this particular cost. If you don't do that, there are market penalties associated with that. That's a powerful business application at that layer. Here's an example of a report that comes out of a system that tells you exactly in real time the status of each unit. Now, the other example, as I said, we talk about is in that particular layer, when we talk about business system integration, is all of the layers below that were purely focused on engineering data. Okay? What would be more powerful is if you take this engineering information and blend it with your business systems. For example, your work management system, your supply chain system, or your financial management system, and say that, hey, I've lost 100 megawatts, a unit outage cost me 100 megawatts, and it translates into X number of dollars of revenue lost to the company. That's very powerful. And that's where we were wanting to get, and that's the work in progress. So I'm going to show you basically how this is going to happen. And that pretty much completes our technology framework. But the bottom layer, the bottommost piece is not a technical piece. It is basically empowering the people to make the right decisions. So let me show you the work in progress. So in the last 10, 12 years, we've rolled out the whole technology platform, technology pyramid, a lot of applications, going from very little data to a lot of data. So if I talk to a person in a plant on, what does he feel about information? Does he have access? Does he have everything on their fingertips? They are actually, they are inundated with information. Their situation is something like this. Okay, so they're confused. Okay, which system, where do I go to get what data, and what is that system's login credentials? So that's a typical user, at least in a power plant. So we're trying to solve the problem of this particular user. So the methodology that we have is if we pool all the information from like systems, like process information into a bucket, business systems into another bucket, market information into another bucket, and pool that information through some sort of a middle tier application and show it to the user on a one single front end. No need to go into any of the applications. It's just going to come into this one single application. And from OSIsoft's perspective, they gave us a tool. It's called Pi Asset Framework. So what it means is one of the other requirements of this particular framework is systems might change. But for that reason, this whole technology should not fail. So systems should be so transparent that the changes should just propagate. And for example, your hierarchy in your work management system might change, but there needs to be a continuous feed into this particular system that synchronizes it all the time. So the changes should get propagated and the user should not get affected. So take an example of a coal mill. So as of now, a coal mill expert can only see engineering information that's available in your DCS and Pi system. But for him to make an objective decision of the overall health of his coal mill, he needs some more information. Same things like production cost information or your reliability metric or your equipment prediction, predictive model output. What is the work management system saying about the work that was performed on that piece of equipment, alarms, etc. So if you want to take this simple DCS graphic and put all that information that I highlighted, all the KPIs, you would have to talk to so many systems. Each system is different technically, so there is no one-to-one correlation. So what you do is you need some sort of a common methodology. For us, we are going to call it as an equipment hierarchy, a logical layer that organizes all of your assets in the company. You take this logical layer and basically design each of your system, apply it on each of your system, then you can talk with all of the systems seamlessly. And once you do that, you have an expanded dashboard that has information from your Pi, your DCS, your smart signals, your KPIs, your alarms, trends, your asset health. In short, if you create a model for just one piece of equipment, and you can replicate it to other like pieces of equipment. Pi Asset Framework is the way to do it, and that's how we're doing it. We've started. We are in the process of doing that work. So just to show you an example of screenshots. So depending upon what your role is, you will have different kinds of screens. A plant executive, a senior executive in the company cares about a fleet-wide metrics. So he'll get some summaries like from a plant perspective, production cost, billing cost, all sorts of costs. If you are a plant manager, you are interested just in your plant, so some details about same metrics, but just for your plant. So there is a logical flow of displays. An example would be a fleet overview will consider fleet-wide statistics from safety, environmental, operating conditions, market information, budget, etc. for the whole fleet. From a plant overview, same metrics, basically drill down at the plant level. And again, at the unit level, same metrics drill down to the unit level. Ultimately, you will reach to an equipment level. So for each display, there is a different audience that looks into that. So from a coal mill perspective, all of those KPIs now are blended into this one. All right, so another report is about the health mill status. So what does total fleet management for us mean? So from a remote operations perspective, it is all the bottom layers of your technology pyramid. When you blend them with your financial management systems, your business systems, and with your market data, that's how you achieve performance excellence. Right?